Okay, so we're going to solve this quiz, and my apologies for using the tablet and getting used to it and being sloppy, but sort of that's the way it is. It's my first couple of screencasts, so I hope you can live with some of the sloppiness. So we're going to look at the first question. Using the distance formula and Pythagorean theorem, show whether the three coordinates make a right triangle. Plot the points and draw the triangle. Okay, I put over here the Pythagorean theorem. So that would be leg squared plus leg squared equals the hypotenuse squared. And the other thing we're going to use here is the distance formula. So those are things that you have to bring into this in order to prove whether or not this this object will be a triangle. So the first thing I would do is plot it. Even though it says plot the points after the first set of directions, I would do that first for sure, just to get a picture of what it looks like. So here's the first point, -1, 3. The next point is 3, 5. Okay, so put it there. Okay, and then 5, 1. So 5, 1 would be right here. Okay, I'm going to use a tool to draw perfect lines here. Oops. Let's see here. I'm going to have to erase that. Really quick. This is the only way I know how to erase. Okay, so back to drawing with the lines. So from here to here, from here to here, of course we're connecting, there's only 3 vertices of a triangle, so that would be the way to do it. Okay, so let's see, let's now label the sides. So if it were a right triangle, this looks to be the hypotenuse, these look to be legs, that looks like it would be the right angle. So that looks like the way it would be if it is indeed a right triangle, which we are going to prove. Okay, so this would be the hypotenuse. Traditionally, the hypotenuse is labeled C, the other two are labeled A and B. So if the Pythagorean theorem holds, then we know it's a right triangle. So if you know 2 sides squared equals the third side squared, if you add them, then we know that this little sucker is a right triangle. So let's go right ahead and do it. So we're going to find the distance of that side for A first. Okay, so we're going to apply the distance formula, and then we will apply the Pythagorean theorem. Okay, so A would be, we're just doing plug and chug using the distance formula here. Okay, so the first coordinate is -1 for x value, and then the second coordinate's x value is 3 squared. Again, apologize for getting used to this tablet. Okay, 3 minus 5 squared. Okay, so that would equal, okay, 1 minus 3 squared, that would be -4 squared plus 3 minus 5 is -2 squared. Okay, so this would be 16 plus 4 square root of 20. Okay, so that's the length of side A. Let's find the length of side B. Let's get right to it. Okay, oops, that's kind of going down. Sorry about that. And that would be from this point to that point, right here to here, right? So that's 3, 5 to 5, 1. Boom, boom. So 3 minus 5 squared plus, okay, 5 minus 1 squared. Okay, let's just straighten this out a little bit if I can. It's really sloppy, I know. So -2 squared plus 4 squared. Okay, so that would be 4 plus 16. Looks real familiar. Okay, so we see that A and B happen to be the same length. Okay, that'd be the square root of 20, that'd be the square root of 20. I'm not going to bother simplifying that because I know that we're going to be squaring these things. Okay, so I wouldn't make it a decimal, I would just leave it as the square root of 20. I wouldn't simplify it, there's ways to do that, but that's sort of another discussion. Okay, so let's get right to the potential hypotenuse, and that would be from this point to that point, here to here. Okay, just going to go right into using the Pythagorean theorem, or excuse me, the distance formula. So it'd be -1 minus 5 squared plus 3 minus 1 squared. Okay, So that would be negative 6 squared plus negative, oops, not negative, that's positive 2 squared. So that'd be 36 plus 4. So that's the square root of 40. And that's sort of looking good because I see it coming. If we square both this and add them, they would come up to that squared. So, but let's just show it. Okay. So square root of 20 squared, this is using the Pythagorean theorem, plus the square root of 20 squared. It's really a question. If this is equal, then we know we have a right triangle in our hands. Okay. So I'm kind of just going to live with some of the sloppiness. Squared. Okay. So yeah, 20 plus 20 really does equal 40. So let's just state it. 40 equals 40. The Pythagorean theorem held true. Okay, you see. Since the Pythagorean theorem held true, that object in question is indeed a right triangle. So let's just write it out. Yes. This is a right triangle. Boom. So I hope you enjoyed it, and we'll do problem 2, and you can tune in for that.